Well, good morning, everybody, and thanks again for being here, guys. Just going to get our meeting going in 5 minutes or so. But hope you guys are comfortable, had a good weekend, and ready to learn a little more logic stuff today. Feel free to say hello over in the chat. Hi there, Arlene. Good to see you. Hey, Rachel. Hey, Jasmine and Jasmine. Good to see both of you guys. Hey, Leo. Hey, Nathaniel. Hey, Valeria. And Natalie, nice to see you too. Good morning. It's a pretty nice weekend. You know, the air quality's better. Now it's fall, so I don't know. I actually like the summer heat a little bit, but it was getting kind of a little rough for parts of the last month. So it's kind of nice to have a little dip in the temperatures. So just about 3 more minutes, and then we're ready to go. Hey, Jamie. Hey, John Red. Good to see you. Hey, Melanie. Good morning. Okay, just another minute or so. Hey, Kalaya and Ruby, welcome back. Hey, Marissa. And hi, Tanya. Okay, guys. Okay, great. So welcome back, everybody. Good to see you there too, Amaya. All right, good morning. Hopefully you guys are doing really well and had a nice weekend. Everybody here in the chat, appreciate your guys' attendance and greetings to everybody. Hi, Isaiah. So today we have a pretty clear goal. We're going to jump into chapter 3 of our book. We've spent a good amount of time looking at the first 2 chapters. We talked about some fundamental concepts of logic, what is deductive validity, soundness, what are the different truth values, what is a logically true, logically false, logically indeterminate sentences, what are equivalent sentences, what does it mean for a set of statements to be consistent, okay? Then we took time to just start working on symbolizations. That was most of the work of last week. And today we're adding another little skill to our growing body of knowledge on logic. So we're going to try and learn a little more about truth tables. We've been exposed to them just briefly so far, as I showed you guys the truth tables for the logical connectives. So for example, we displayed all the possible truth values that a conjunction can have, that a disjunction can have, that an if-then, material conditional, biconditional, and negation could possibly have. So we are now going to try and learn how to use truth tables to evaluate individual sentences to determine whether or not they are logically true, logically false, or logically indeterminate. And to everyone arriving, I see you guys, and it's good to see you, April, Alicia, Arlene, Josephine, Stephanie, Loveth, Yvette, and Ella, everyone there. Okay, truth tables for any random sentence that we see in the symbolic logic of SL. Now, in our book, I'm going to start with an example that's provided here. On page 71 of the textbook. So let's start off kind of easy. Suppose that I have a statement like this. A and B or C. Okay? Now, to create a truth table for this expression, we have to draw a cross. Okay, so we begin by drawing a cross. And the expression that we want to analyze is at the top right of the cross in that quadrant that you see there. Now, before I continue to create the truth table, what I want to do is place a downward arrow above the main connective of this formula. So tell me, what is the main connective of this sentence of SL right here? You see there's 2 connectives in there. One of them is a conjunction sign, and one of them is a disjunction sign. Which of these, if you can place in the chat, is our main connective? Correct, Arlene. It is this one, or. So we're going to place an arrow downward facing over the or. Now, when you have a compound expression and one part of it is nested within parentheses, the outer connective is going to be treated as the main connective in that case. So this disjunction sign is our main connective. Hold that thought and we'll come back to it later. Now, here in the top left of the truth table diagram, we have to create, we have to list all of the sentence letters, all of the atomic sentences of this molecular statement here in alphabetic order. So what should be written up here on the top left? What capital letters in what order are going to appear there in the top left of this truth table? That's the question I have. What to be written here? A, B, C. That's correct, Lily. And also Ruby and Evelyn, yes. So the letters that appear in this formula are A, B, and C. And they simply get replaced over here outside of the overall formula in the alphabetic order they occur. Now, does anybody remember the rule for how many rows we will generate in the table? What is the rule? And maybe one of you will tell me and then I can just repeat it for everybody. But I'd like to see if there's a memory in your minds. Yes, well, it's actually 2 to the power of n, where n is the number of sentence letters. So it's not 9 actually, Frida, no. It's not 3 times 2 either. No, that's false. It's 2 to the power of n, where n is the number of sentence letters. What is 2 to the power of 3? It is 8, correct, Natalie. So basically it goes like this. With each additional sentence letter, starting with only 1, there would be 2 rows. And then with each additional sentence letter, it gets doubled. So from 2, 4, 8. All right, so we're going to have 8 downward rows. And the top half of the leftmost column is going to be T's. And the bottom half of the leftmost column under A are going to be all F's. So since we have a total of 8 rows that are going to be following underneath A, tell me what's the order that they will appear in. Sorry, Eddie. Yeah. So since there are 8 rows here, I'm just asking you, what will the display look like underneath A? We will have a series of 8 rows following under A, given the fact that this is 2 to the power of 3 rows for 3 sentence letters. So 4 T's, then 4 F's, correct, Lily? Okay, now, the reason that we do it in this systematic way is to demonstrate all possible combinations of truth value for all the sentence letters grouped in the formula. So as we slide over to the next vertical column, it's still got 8 rows, but in this case, what's the pattern of T's and F's? In that second row underneath B going down, what should be displayed? It's not 4 by 4 T's and F's, as in the first case. The rate of alternation exactly, Natalie, doubles in frequency. So whereas this is 4 by 4, giving you a top block of T's and a bottom block of F's, the next one will be 2 by 2. So you will see T, T, F, F, T, T, F, F. Okay? Now the rule is that as we go to the next right vertical column, the alternation of T's and F's continues to double in frequency. So what shall it say underneath C? Please just write down the 8 letters of TF in whatever sequence. Good, Natalie, that's correct. So it's single alternating here. TF, 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 TF. Okay, now with this fully filled in, we see every possible way of assigning either a T or an F to the 3 sentence letters in this expression. And this is 8 combinations possible. The first combination where each one receives the letter T. The second combination where these 2 are true and C is false. A third combination where A and C are true, but B is the false member. A fourth combination where only A is true and the others are false. The fifth combination has false A with true B and C. The sixth combination is where only B is true and the other 2 false. The seventh combination in which only C is true and the other 2 are false. And finally, in the last row, the case in which all 3 of the sentences are false. Okay, now, as we slide over to this side of the truth table, we then have to place T's and F's in each one of the horizontal rows in accordance with the truth value assignment that you see there. Now these 8 rows can be called 8 truth value assignments, all right? They're all unique. This truth value assignment is not the same as any of the other 7 because in all other 7 cases, A, B, and C receive some different combination of T's and F's taken as a whole. So we have 8 truth value assignments here, and that means we're going to have to create 8 rows here with the T's and F's assigned as seen in that row. So tell me, in the first of these 8 rows, what is going to be written underneath A, B, and C? Just let me see in terms of T's and F's going from left to right. A, B, and C. What is to be written in the first horizontal row? T, 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 exactly, Frida. All right. And little Eddie, sorry boy, just gotta step down. Good boy. Okay. Now, if that makes sense to you, then hopefully this next part will be pretty straightforward. What is to be written here, starting from A, then to B, and then to C, the second row now. Tell me the second row and what to write underneath A, B, and C. Good, T, T, F. In the third row, hopefully we all follow. Here's the third row, and in accordance with the truth value assignment, sorry, I'll put Eddie to the next room. He's just being too rambunctious. Good boy, I need you to go in there. All right. Sorry, guys. Yeah, so third row, everyone sees the third row? Okay, Evelyn, your question, why is it all T's again in the first row, Evelyn? It's the same as seen in this part. So if you just isolate your focus to the top row, TTT is derived from what is written here. Okay, and in the second row, TTF is derived from this key that you see here to the left. Yes, it's the same from the other side. Now, as we go to the third horizontal row, this is a new truth value assignment. The third one here says what? A, B, C are going to receive what three truth values? In the third truth value assignment, it is what? TFT. Okay. In the fourth one, now we can maybe speed up a bit. This is TFF. And it's not guessing or guesswork. It is an exact correspondence with what is here. So it's totally algorithmic. In a way, there's no thought. It's just the table dictates what must be written. And in this case, FTT. Finally, well, not finally, there's three more. FTF. Seventh is FFT, F. But our table is not yet full and filled in completely. So we always do the main connective last. So having set this arrow above the main connective, we're going to wait to fill this in until everything else is done. That means that after we designate truth values to each of the sentence letters, we then go to the subsentential expressions, like this conjunction over here in parentheses. So for the moment, we're just going to be placing a truth value in each column, in each row, underneath this AND symbol. So we're, for the moment, just focusing on this part of the compound expression, A and B. All right? Now, if you remember the semantics for conjunctions, there's only one case in which a conjunction is true. And what case is that? A conjunction, an AND statement, is only true if the two conjuncts are what? Both true. Exactly, Andre. So knowing that, help me fill in each of these 8 items. In the first row, where the left and the right conjunct are both true, what is the value of the conjunction? So basically, T or F, what goes here? In that case, T, correct, Leo. And yet again, T and T in this second row. So we yet again have the case where it's true. But now in this third row, they're not both true. B is false, which would render the overall conjunction as what? Now we are looking at this third row, where the value of A and B is T and F. That gives us the value of it being false, correct? Because again, with a conjunction, they both have to be T on the left and right to receive that truth value. So if you have one F or both, it's false. What then in the fourth case? Another case where it's false, because of the right-hand member. In this fifth assignment, it's also false, but now it is because of the left member. In the sixth assignment, yet again, the left member being false makes it a false conjunction. And then in these two cases, of course it's false, because both of the conjuncts are false. Now, to finish the truth table, we have to now place 8 truth values underneath the main connective. Now, this is the disjunction symbol, okay? And the disjunction symbol has its own logic. Who can remember how many of the disjuncts must be true for a disjunction to be true, for an or statement to be true? If I say that I will either study logic or history today, it only requires at least one. Good. So a disjunction is only false when both of the disjuncts are false. But if even one of them is true, that's enough for it to be true. Now, in filling in underneath this wedge disjunction sign, we're going to be comparing the left and the right side of it, okay? Now, on the right side, we have an atomic sentence, C. And so that's easy enough to evaluate. It's just this row of 8 things here. On its left side, though, which part of this formula are you going to use to compare with the right-hand side? You're going to use what's underneath the connective of the subsentential expression. So basically here you're looking at the left underneath the and sign and at the right underneath C. Those are the two values grouped by the disjunction symbol. And that will give you the ability to fill in this blank space. So in the top row, we have T, T. And that means that in the top case, the disjunction is true or false. So in that top truth value assignment, I have to write T or F. Correct, Ruby. True. Why? Because both of its left and right side components are true. And if even one of them was, that would be enough. But both is also fine. So now we go to the second row. Row number 2. What's its truth value assignment? To be clear, because I think this will clarify, when you write your answer for me, let's add a slight prefix so that in the chat it will be a little bit more clear to anyone now or in the future. So write row 2, colon, and then tell me what it should say. You're getting it right, but let's just add that little level of precision. Row 2, colon, yes, true. Okay, good. Why? Because of this member on the left underneath the and symbol. That's a T, and so that's enough. Now, row 3, telling me what truth value row 3 receives underneath the disjunction sign, underneath the main connective. Row 3, also true, correct. On the basis of what? The right-hand member. Okay, now we've got row 4. And what's up with row 4? Who will tell me about row number 4? Row 4, correct, it's false. Sorry to say, Loveth and Ruby, it's not true, it's false. Let's be very clear as to why. Why is it false? Because this says F on the right, and this says F on the left. It's a disjunction with 2 false disjuncts. And that is the one case where a disjunction turns out to be false. Like if I say to you that right now I'm either wearing a hat or earrings, that's a false statement because I'm not wearing a hat nor am I wearing earrings. So I would be speaking a falsehood if I said that. So in case the right disjunct and the left disjunct are false, the disjunction is false. So you look, what you're looking for to determine this value are the things on the left and right. If there's any T's, it's true. But in this case, comparing this piece to this piece, they're both F. Now we move to row number 5, okay? Tell me about row 5. What's the truth value of row 5? Row 5, true, correct. Which disjunct makes it true? The left side or the right side in row 5? Which of those 2 disjuncts is the member of the disjunction which makes it be a true statement? The right side, correct. This term being true. This one is false, but this one's true, so one of the disjuncts is true. And that means the disjunction is true. Now we're looking at row number 6. And what's up with row 6? What is the truth value of row 6? Okay, Arlene, Isaiah, Natalie, good, correct. The row 6 is false. And why? Because of the left side being F and the right side also being F. So without anything true, it's a false disjunction. Okay, 2 more. Row number 7 will be assigned a T or an F. Row 7 receives T, correct. And that is again because of the right disjunct in that case. Now, finally, in the final row, row 8. Row 8 is false, yes, because, well, everything's false, so it's kind of easy enough to see. And that means that both disjuncts are false. Now, when we've completed the table, which this is now a completed truth table, we're going to circle above the main connective down. We're going to circle that vertical column that falls underneath the main connector. And now I need to tell you this. When you look at this in the end, you're going to see a display of either T's or F's. Now, here's a rule. If when you complete the truth table, there's a combination of T's and F's, that means that this sentence is logically indeterminate, because it means that there's a possible world where it's true and some possible worlds where it's false. So since it could be either way, that means that it's not logically true nor logically false. It can be one or the other, true or false. So let me maybe go to the other side of this board so I can write a little information over here. So if circled column has all T's, then the sentence is logically true. Okay? If all F's, then it is logically false. If a combination of T's and F's, if both T's and F's, then logically indeterminate. Okay, I know it's a little. Based on that explanation, tell me, what is the status logically of the sentence? Is it logically true, logically false, or is it logically indeterminate? The formula written here on this board. And that's the main question now to ask. And you have enough information here to give me the answer. So, is this sentence A and B or C? It is logically indeterminate. Correct, guys. And why is that the correct answer? Because as you look at this circled column, it's not everything T, it's not everything F. There's T's and there's F's, which means that it is logically indeterminate. So you're going to be, doing problems of this kind. You'll get some problems in which you have a formula, you create a truth table for that sentence, and then you'll use the truth table to give me the answer. Is this sentence logically true, logically false, or logically indeterminate? Every sentence in logic is exactly one of those three and never more than one. So this would be the method by which you would determine whether that was true or false. So if I told you that I have either an apple and a banana or a carrot in my lunch bag, right? That would be true if I had all three things, okay? It would also be true if I just had the apple and the banana but not the carrot, because I said I either have both of these or one of those. Another case in which it's true is where I have the carrot but not the banana, and I do have the apple. So in that case, it's false that I have both of these things, but it is true that I have the other item, which I mentioned, that I would have either both or the one or the other. So that makes it a true disjunction. It would be a false statement if you looked in my bag and all you saw was an apple, because I said I either have both of these or a single carrot. And if I have no carrot and I don't have both of these, then that was a false either or. And on for the remainder of them, okay? So since the statement can be true, depending on the contents of the bag, or it can be false depending on the contents of the bag, there's a way for the statement to play out as true or false in different possible scenarios. Thus, it's logically indeterminate. Okay, and let me do another one from the book. We're just going to get more of these practice problems developed today and get our feet wet with the whole truth table method of analysis. So next, let's try this one. I see this one in the book on page, they first introduced it on 72, and they take a couple of different attempts to fully express it. So let's try this one. Okay, so what we're going to have is both, if not B, then C, and, so I'll try the ampersand, A if and only if B. All right? Now, it's a little more complex, but I'm going to just keep scaling up the difficulty slightly. Tell me first to start, what's the main connective here of the formula written there? The main connective, the one that I will draw an arrow pointing down above. It's the and sign. That's right, Lily. Because the other connectives are grouped within parentheses. And this is the thing that joins the two parenthetical expressions. So it's the thing that would be analyzed last, and thus it's the main connective. Okay, now over here to the top left, yet again, I have to list each sentence letter in alphabetic order, using this formula as my material. So what is to be written in the top left, in order from left to right? It's pretty simple. It's just A, B, C. That's right. Okay, and so let's quickly say, how many rows will this formula need in its truth table? We need a total of, how many rows it is again? The number 8, yes, because there are 3 sentence letters, and 2 to the power of 3 is 8. So underneath A, what is the display going to appear as? You can just put it as a sequence of T's and F's in the chat. The downward vertical display underneath A should appear and read as what string of letters? 4 T's and 4 F's. Okay, and as we move to the right, B, the following column, get in the habit of kind of making this a little bit automatic in your mind. What is the B display? It is always T's first, correct, Evelyn? Yes, that's right. So it's like the first half of the leftmost column are all T's, and the second half are all F's. So that's why you have half T's, half F's. But then as we go over, we just alternate with twice the frequency. So instead of a 4x4, we'll have a 2x2, which means that going downward, the B column should appear how? Tell me somebody, B, underneath the, yes, correct, Ruby, TTFF, TTFF. So we get to the 8 columns, but by means of alternating with a different rate of frequency, sorry. TTFF, TTFF. Finally, the column facing underneath C. Just let me know what happens underneath that one. We have 8 items, yet again, as in all 3 cases. But the display of T's and F's will appear a little different. And in this third vertical column, yes, Ruby, it is TF, 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 TF. Okay, so that part is all filled in. Now, when we come over to the right, we simply use the truth value assignments of each horizontal row to replace T's and F's under A, B, and C. Now, as I did it last time, I went horizontally, row by row. We could also go vertically, column by column. So underneath each occurrence of B, if we like, we can simply match the pattern seen here. So it would look as follows, T, T. So I'm doing the vertical method. There's 2 methods by which you can fill these truth tables in. We just did the horizontal method. Now we're going top to bottom method. So underneath B and each occurrence of B, we're going to create a replica of this. T, T, F, F, T, T, F, F. And here's another case of B. Okay, so what's next? Let's say we'll do the C column, all right? Now going down underneath C, if you follow me, that's going to mirror the downward vertical display underneath this letter. So it's just going to be a row of single alternating T's and F's. Okay, and then finally, there's one case of A, and underneath A, we will yet again generate a column that looks just as like that you see here. So that's 4 by 4. Okay, now we will not do the ampersand until the end because the main connective is saved for last. That means that we have to now choose which side do we want to do first, this right-hand parenthetical expression or the left one. Any preference, guys? Leo, question. Does the tilde on the B only affect it when we're deciding the true value as a whole? We'll talk about that just now. But the tilde that's attached to B is going to reverse whatever is written under B. So you know what? Since you're asking that question, let's start on the left, and I'll cover your question as we do it. So here's this tilde sign. The tilde is attached to B. It's negation of B. So as you guys have learned, when you have a statement, and let's say the statement is true, when the negation is given to it, that makes the statement false, and vice versa. If you have a statement which is false, and then that is negated, that flips it back to being true, right? So like right now, it's Monday, and that's the truth. If I say it's not Monday, that's not the truth. That's negating something true, which is saying something false. Now, it's Tuesday, that's false. But if I deny that, I've denied a false statement, and thus I'm saying, so if I say it's not Tuesday, that is correct, because it isn't Tuesday. So to deny something false is to speak the truth, and to deny something true is to speak a falsehood. So knowing that and remembering that, let's do the 8 values that fall under the tilde here. And it should be easy enough. So what gets written here to the left or underneath the tilde in the first horizontal row? Let's see who can tell me that. So I'm looking at this tilde sign, and I'm looking at what to write underneath it in each of these 8 cases. So even starting with the first one, what will the first instance of the truth value? That's a question for you. I can't give you the answer. No, no, Frida. It won't say T. Lily, yes, it will say F. But no need to guess, though, Frida. It's a very clear answer, and here's why. This says T. B already says T. So a tilde attached to it is the opposite. And there's only 2 possible values. There's T and there's F. So this F is the opposite of T. False is the opposite of truth. Since B is true, the negation of it is false. So what about the next case? Row 2. Tell me row 2, colon, or 2 somehow, so I know we're talking about the same row. What's the value underneath the tilde in row 2? Row 2, F, correct. For the same reason, T reversed is F. Now, row 3. Row 3, the value assigned to the tilde in row 3. Exactly, yes. Why is that? Because B in row 3 has been assigned false. Negating it, thus, is to say something true. So we continue. Row 4. Row 4. Correct, Kalaya, yes. Row 4 is true, owing to the fact that its immediate subsentential expression, or its immediate sentential component, is false. And here in this case, row 5. Row 5. Row 5, good. False. Exactly, Arlene. Because again, the function of tilde is simply that it reverses whatever it is attached to. Okay, so since it's attached to B, we simply look at B, whatever its value is, it's going to have the opposite under tilde. So yeah, what about row 6? Row 6 should simply say F, yes. And then in row 7 and row 8, let's just tell me about row 7 and 8. Yeah, row 7, row 8, both true. Because B on those 2 assignments is false. All right, so we've finished that part, but we are not yet done with this whole formula. To finish, we now have to draw the value underneath the arrow or the horseshoe sign in these 8 cases. So to do that, let's see who can remember the truth table for if-then. For the if-then sign, or sorry, Andre, let me get a question. Do we have to write the truth values under the tilde? I ran out of room, but I know what the truth value is. Yes, you have to write it. Yeah, for sure you do, because me evaluating it, I'll never know if you understood the correct answer unless you present it in the written form. So you do have to show it. It's like it's kind of like in math. If you just write an answer but you don't show how you arrived at the answer, then you might have used a calculator or something. But it's even worse than that in a way, because you'd still have an answer written in the math case. In this case, it's incomplete, and therefore not analyzing the expression 100%. Even if you have a mental understanding of it, yes, you have to commit it to the page, but no big deal. Okay, so we still have to finish this part underneath the conditional sign. So who remembers the truth value of if-then? There's only one case where A then B is false, okay? Tell me in what case it's false. Good, Lily. So an if-then conditional is always true except in one specific situation, the one you're mentioning, where the left side says T and the right side says F. Now, what's on the left of the arrow is going to be the value under this left side component. And since the tilde is the outermost part of it, we're going to compare the letter under the tilde with the letter that is underneath C in the formula. So those are the two pieces that you're going to look left and right to judge what the truth value is in each of the 8 cases. All right, so row number 1. What's the truth value in row 1 underneath this arrow? Let's see if we can get that. So just say row 1, right, colon, and then what is your answer? The first row of this truth table under the conditional sign. Okay, good. True, exactly. And that's right. Why though? Because to the left is F and to the right is T. Now that's not the combination TF. And that's the only situation where you would write F underneath this arrow sign. So all other possibilities, TT, FT, FF, 3 out of 4, it's all true. The only 1 out of 4 possible case where it's false is where you have a true antecedent and a false consequent. So yes, this is true. Let's talk now of row 2. The second row. What's the truth value of the conditional there? When you have F leading to F. Correct, Natalie, also true. In fact, how about this, guys? Let's see if we can use a little logical deduction. What's the, how many rows total here, and which ones show this conditional being false? Let's just kind of work in that indirect way. So give me the number of row or rows where I should write an F underneath this arrow. Sorry, Leo, it can't be 2, because Leo, we already did 2. 2's done. So that's, I mean, and it already says T. So certainly it can't be that. Okay, so here I see Arlene, row 4 and 8. Yes, that's correct. Row 8, yes, Kalaya, that's true, but also row 4. Meant only 2 rows are false. Ah, I see what you're saying. Never mind, I got it. Okay, yeah, so row 4, see here, T, F. So that's a false material conditional. Row 8, yet again, T to the left, F to the right. So thus it's a false conditional in that case too. And since there are no other TF combinations, all the others were true. But we're not yet done, okay? We're not yet done because there's still 2 more columns to fill in. So we have to now fill in under this triple bar, or you may use the double arrow, right? So that's an if and only if statement. Let's remind ourselves, let's refresh our memory about what are the rules for the truth value of biconditionals. When, in what situation, is a biconditional statement true? What truth values must its 2 left and right components have for it to be true? The truth values must be the same, correct, Andre? So they can both be T, or they can both be F, but if they are 1 T and 1 F in any combo, that's false. Okay, so visually, you're looking for like a matching pair when it comes to the triple bar, double arrow, biconditional. So essentially, again, I'm reminding you, if you see a TT, that's a true biconditional. If you see an FF, also true. But any other combination where they don't match would make it be false. So start with row 1. Tell me, what's the truth value underneath that biconditional symbol in the first row, row 1? Row 1 receives the value. It's got to be one of the two, T or F. So which one is it in that case? Row 1, T. Correct, Andre. Why is that? Because A and B are both assigned the truth value T in that case. So they match. How about row 2? Let us mention row 2 then. Good, we got row 1. Perfect. Row 2, in this case, just tell me. Row 2 also true, exactly. Because yet again, same thing, no difference. True on the left, true on the right, so it's true. Row 3. Row 3 of this table. Let's hear about row 3. We got the right answer for 1 and 2. Row 3, F, correct, yes. And what's the reason? Well, because as you can see in row 3, the two terms on the left and the right are not matching. There's left term T, right term F, so they don't match, they're not a pair. That makes it false. So hopefully that kind of makes it easy enough. What is row 4? Row 4 is the value row 4 is an F, yes, because they don't match. In fact, how about this? Just tell me, when it comes to, well, we'll just do it quickly. 5 and 6, you can see. Hopefully you're getting the picture. These two don't match. There's F and T in the combinations of these two rows. So they're both false. And in these bottom two cases, the biconditional is true because you have matching Fs. Okay, so like you can see that in the bottom two rows, where the truth value given to A and B is F, that makes the biconditional, which groups them true. Okay, so now we've reached the ultimate column, and this is an and sign. So the rule is that we're going to take two terms, one on the left, one on the right, to analyze its truth value. The term on the left is going to be the truth value written under the main connective of this expression, and the term on the right that we will use is the truth value written under the main connective of the right-hand expression. So basically, we're looking at what two parts to create this final assignment. We're looking at the truth value under what and what. Tell me that. So on the left side, what's the connective that we will look underneath to fill in this final column? On the left side, we look at the truth value written underneath what part of the left side? What's written under the arrow? Correct. Good. On the right side, we look at the letter that's written under which part? To the right side, it will be the double arrow. Yeah, sorry I had a triple bar up there, but good. Okay. Now, what's the rule for a conjunction again? For it to be true, what has to be the case? For an and statement to be true, we have to have both of the conjuncts being true. Yes, Lily. So you're looking for two T's. If so, it's true. And if you don't see two cases of T, it's going to be false. All right? So row 1. Tell me what goes underneath the ampersand of row 1. Is it a T or is it an F? Row 1, truth value for the ampersand. T, correct, Melanie and Lily. And that is simply because this and this, underneath the arrow and the triple bar, they're both T. So we go on to the next. Row 2. What should be underneath that ampersand, a T or an F? Row number 2. Again, good job. Yes. What? No, sorry, Ella. Wrong. It's true, because just with the first row, it's the same. T, T. And look here, T, T. They're both true. So there's no member underneath these two parts that is false. Thus, it's true. Okay. Just keep in mind that you're not just looking at everything to the left and everything to the right when you fill in this last truth value. You're just looking at the value under the main connective here, this part, and the value under the main connective on the right, this part. Oh no, it's fine, okay. Well, teachable moment whether you had the wrong type or not. So let's go to the third case then. Row 3, Tell me about row 3. This should say T or F. Row 3. F, F, good. That's correct. Tell me why. Somebody, please explain why it's false in the third horizontal row. Just want to check and make sure we have the common understanding here. So yes, it's false, and good, Loveth. It's because the right side exhibits F here. So they're not both T. You have one T, but then one F, so it's false. False conjunction. All right, so we move to row 4. Row 4, what's that truth value here? T or F? No. Sorry to say, Jamie. Not the case, no. It's not at all true. Why have you said true? We're looking at a conjunction in which both of the conjuncts are false. So let us say, what is 4? The truth value in 4. Oh, no, it's okay. But anybody can please tell me, because I haven't seen anyone yet provide the information. Number 4, the truth value underneath the ampersand. It does say F, correct, yeah. What's the reason this is F? Because we don't have two things on the left and right that are both true. In fact, they're both false. False, false. So that's a false conjunction. Okay, so tell me about row number 5. 5 is what? In fact, how about this? How about this? I know I just asked you about row 5, and you may answer that if you wish, but I'd like to just ask a sort of different question also. Out of the remaining 4 rows where we're going to place T's and F's, which case has a true conjunction? Out of 5, 6, 7, and 8, tell me which ones of those 4 are actually true. Yes, only row 7. Only row 7 because of this T here and this T here. So since all others have at least one of the components on the left or right as false, they're each false aside from that one. So we're done with the table. We circle the column here that falls underneath the main connective. And based on our rule here to the right, what kind of sentence is this? Is it logically true, logically false, or is it logically indeterminate? It's one of those 3. It's logically indeterminate, correct, Lily? And why is that the right answer? Because as you examine this circled column, there's a combination of T's and F's. So if it was logically true, they would all be T. If it was logically false, they would all be F. Since there's some T's and some F's, it is thus a logically indeterminate statement. So another practice problem there. I want to then start us looking at some more of these problems in, let me get to the section 3.2, okay? So I'm erasing this one off the board, and we will just try another. Okay. So let's do this one. This is problem 3.2.1b. So I'm doing some problems now in this problem set, 3.2 part 1 on page 85. So for those looking in the text later or even now, you can refer to that part of the book. So problem B. Now the problem itself has this formula for us. If J, then in that case, if K, then J. All right? So it's a conditional, which has as its antecedent the atomic sentence J, and as its consequent, it's a nested conditional, which says if K, then J. Now, what is the main connective, first of all, of this formula? one of the parts of this sentence should have an arrow pointing down over it. And that will designate that that'll be the last component to assign a truth value to as we finish the table. So who can tell me which one of these symbols it is that will be the main connective? The first arrow symbol, correct. The page that we are looking at is page 85, and it is question 3.2.1, letter B. Okay, Jamie. So there you go. Correct, everybody. It's the first arrow. Well, Ella, a little, you'd have to be more specific because there's two of the arrows. So it would be precise to say that it is the initial one here. Okay. Now, how many sentence letters are here? No problem. Thank you, Jamie. So there's how many sentence letters and what order do they go in alphabetically? That's what I put up here on the top left. So to the top left, just write in capital letters what I have to put there in what order. JK, right? Not just kidding, but yes, JK in the alphabetic order because J comes before K. Now tell me, how many rows does this truth value need? How many truth values? Sorry, rows is what I meant to say. How many rows would this one need? 4, correct. Because there are 2 sentence letters, and the total number of rows is always 2 to the power of n, where n stands for the number of sentence letters, unique sentence letters that you have. So there's 4 rows. Now underneath J, what will the downward facing display look like in order of T's and F's? Just tell me that. Now the rule is that the leftmost column, the top half are T's and the bottom half are F's. So with that, you should be able to tell me what will it look like underneath J. Correct, guys. T, T, F, F. Underneath A, we shall have 4 rows, and they will also have T's and F's, but in what order? Starting from top to bottom. And again, the rule is always just that whatever the rate of alternation of the current row, the next subsequent row to the right will have the same number of rows, but it will alternate T's and F's twice as frequently. So correct, Kalaya, this is going to say TF, TF. And once again, this shows you every possible way of combining T's or F's in assigning them to these 2 sentences. One possible world is the world where J and K are both facts. Another possible world is where J is a fact, but K is false. A third possible world is where J is false, K is true. And finally, we have the situation in which they're both false. So we'll now fill in underneath these expressions using this table. How do you prefer me to do it? Do you like the horizontal method or the vertical method? I mean, everyone, I guess, will have their own way of preferring it, but does anyone have a request? I guess it's the same thing, but, you know, sometimes students will have a preference. Anybody? Vertically? Okay, let's do it vertically then, Arlene. So underneath each occurrence of J, we simply have to have this 2 by 2 downward display. When I say vertically, what I mean is that I could have also gone horizontally, and I could have like filled in J and K left to right by consulting each horizontal assignment. But vertically works just as well, and it will receive the same values by the time it's all filled in. So with the other occurrence of J, yet again, it's 2 by 2. And under the one occurrence of K, we have that TF, TF vertical display. Now, since this is the main connective, we save that for last. And now let's go ahead and show the value underneath this arrow, okay? And, okay, yeah, so I'll do the next one horizontally, Kalaya, so we'll just kind of get a balance. But anyway, underneath this arrow, we have 4 things to write. 4 either T's or F's. And you remember the semantics of conditionals. There's only one and only one case where it will be false, and that is when the left side is T and the right side is F. So tell me, which of these 4 cases, which of these 4 rows will be a row where the statement is false? We have 4 horizontal rows, 1, 2, 3, 4, going from top to bottom. Yes, so in the third row, this is a false conditional because T leads to F. But is there any other of these four cases where there is T, F in the left-right combination? No. In this case, it's T, T, F, T, and down here, F, F. So since none of them are T, F, the rest of them are all true. Okay, now, the final row is this one. And in this case, we are going to compare what two parts of the formula to generate the last assignment. Well, on the left, it's easy, right? So on the left, it's the truth value that's written under J. And on the right, we're comparing that thing on the left with what on the right? The value that is written underneath what part? So I just need to know what the left and right terms are. Yes, the truth values that are underneath the arrow, namely these four values. Because this arrow is the main connective of this subsentential expression. So we're basically looking at J and arrow, those two letters, to figure out what to write here. So in the first horizontal row, what truth value will I place under this left arrow? So just tell me row 1, the truth value to put here. It's a T or an F, but which one? So in that first row, correct, true. Why? Because T and T are both on the left and right. Row 2, what's the truth value of row 2? The truth value of the second row. And wait for it, it's T yet again. Good, Isaiah. And the reason for that is why? Because of the fact that, yet again, it's a left term which is true and a right term which is true. So it's a true conditional. It's not TF. Now in the third case, what's the truth value here? Row 3. Row 3 receives a T or an F. Good, Loveth. The answer is yes, correct, that it will be a T. And again, why? Because F and F is not T leading to F. F to F is a true conditional, just like all of them are, except for T to F. So finally, the fourth case, F leading us to T. That is what? The final row, row 4. This will be a T or an F. It will be, let me know. Good. Another case where it's true, exactly. Why? Because as before, as mentioned, the only situation where a conditional is false, like this is only false if you have true and false to the left and right. Left side true, right side false. But all other combinations make it true, which is what we see here, F going to T. So now we will circle the column under the main connective. And I have the question again, what's the status of this sentence then? Is the sentence logically true, logically false, or is it logically indeterminate? There's a precise answer. It's one of those three. Which one? Okay, good, Natalie. Logically true. Also good, Arlene, Valeria, and the others. And why is that? Why is that easy for you to see, even just visually? You can tell that it's logically true because when this truth table is completed and the main connective column is circled, you see a display which only shows the letter T. And that's what it must look like if it's logically true. So this is a logically true one. If there's a combination, some T's, some F's, that's indeterminate. If it's all T's all the way down, it's logically true. And if it's all F's all the way down, then it's logically false. So in other words, like the statement which says if something, then if something else, then the something is logically true. Like if I say to you, if I drink water, then if the world is round, then I'm drinking water. It's kind of like tautologically necessarily true because in case the first part is true, then obviously the second conditional must also be true because the antecedent being true is going to guarantee that this last consequent term is true too because they're the same letter. So you'll never get a situation here where this is leading from T to F whenever this is true. Thus, you cannot have a T to F combination, and thus it's a logically true statement. Let's try another example. Okay. Wait, quickly I'm going to do something. I just want to look at one of my sample answers so that I can make sure I give you one that exhibits some features we haven't yet looked at. And I'm just like looking at another screen here for 2 seconds, so bear with me as I do that. Okay, here we go. I'm going to create one just off the top of my head. So suppose we have this formula. A and B and not the case that A and B. Okay. So what this says is A and B and not both A and B. It's kind of a weird thing to say, but first of all, what should be our main connective here on the right-hand side of the cross? The main connective that I'll draw a downward arrow above. It should be above which symbol? I'm just asking about the main connective of this formula. So the second conjunction sign, this one. Yeah, so it's above that. Now over here to the top left, I just need to generate the letters that the whole formula has in alphabetic order, which is straightforward. What's the ordering and letters in the top left? A, B. Okay, good. Now, how many see, practice makes perfect. The first couple times you do this stuff, it's a new skill, but intellectually, I know it's not something that's impossible to master. I know a lot of people have done this throughout history, and you're not the first, so you'll be in good shape. But yeah, there's A and B there. And how many rows, though? We will need a total of, give me a number. The full table will have how many of these horizontal rows within it? With 2 sentence letters, we know the answer. It's 4. Okay, good. By the way, just let's see if you can follow me here. If there were 4 sentence letters in this, not this one, but in a different example, if there were 4 sentence letters, then how many rows would that example need? Just to make sure you understand that, because we haven't done one with 4 sentence letters yet. We've done 3. Now we've done 2. Yeah, so there'd be 16 if there was an additional sentence letter, and basically a double starting from 2 with each new sentence letter. So if there was 1 sentence letter, it's 2. If there's 2, it's 4. If there's 3, it's 8. 4, it's 16. Okay. But yeah, there's 4 rows here. Underneath A, we're going to have 4 items, and it's going to be T, T, F, F, as we've seen before, and that's always going to be the same. So like the first part of setting up the truth table is kind of just automatic. It's algorithmic. There's no ability to be creative. It's just, that's the rule. There has to be 4 of these columns. Underneath B, it's 1 by 1, TF, TF. Okay, now, to fill in, let's do it the horizontal way this time. So the first row is the row where A and B are both true. So we're just going to write T under every letter. The second row is where A is true, but B is false. So in that case, every case where there's an A, we write T, and every case where there's a B, we write an F. In the third truth value assignment, A is the false member, and B is true. And then finally, in the fourth case, they're all false. Now, we saved this main connective area for last. So let's just work on the stuff that's inside of this conjunction. So we got 4 letters to add to the table, and they're going to fall underneath this conjunction sign on the left. Now, we've learned about the rules for conjunctions. So talk to me about the first one. What is the letter given here? Is it T or is it F? Row 1, under the leftmost conjunction sign that we're examining. Yes, Ruby, it says T. Because both of the two both of the two components connected by the and sign are true. Second row number 2, is that T or is that F in row 2? Good. Yes, F. And can you just tell me about row 3 and row 4? Do they have the same truth value? If so, what is it? What is that? Just let me know about row 3 and 4 if you can. As we fill in the last 2 parts of this column here. Both F. Good, Arlene. As you guys remember, a conjunction can only be true when both of its component parts are true. So one being false, it makes it false. Or both, yes, that makes it false. So we still have to finish this side over here. And this is another case of A and B. So it's going to have the exact same display, at least that part. But there's a tilde on the outer side of this conjunction. Now the tilde we have to fill in underneath it. And it's going to display a value here that will reverse the truth value of what component. So I'm asking you this. What will I look at within this formula to determine what value to write under the tilde? I'm looking underneath the what part of that right side formula. Because you see, the negation sign always has to reverse something. And yes, Arlene, it reverses the value of the main connective seen in this expression. So basically, whatever this thing says, we're writing the opposite under the tilde. So just tell me, row 1, what should be under the tilde? That first row under the tilde, will it be a T or an F? Row 1, truth value, under the tilde. That's the question. Good, everyone. F. Why is that? Well, it's because in relation to this, that's the opposite. And this is the thing that gets negated by that tilde sign. So since this was T, this says F. What about row 2, 3, and 4? Underneath that same tilde sign. Going down, what will be the 3 truth values displayed in row 2, 3, and 4? Yes, Jamie, the rest are true because they are the negation of a false conjunction. So T, T, T. Now we're almost done with the table, but we have one more column to fill in. And this is the column that falls under the main connective of the whole compound formula. So to generate these 4 values, we have to look at the thing on the left and the thing on the right. Now, what is the main connective of the left-hand expression? So what part of the formula are we looking at on the left to fill in this final conjunction sign? We look underneath which letter or symbol? The and sign, correct, Arlene? And then to the right, what will be the symbol or letter that we derive the right value from? Let me know about the right side. Yes, Arlene, good, it's the tilde. The reason it's the tilde here is because this is outside of the conjunction, and it has to have the value of the conjunction established in order to negate it. So the last operation you would go through in giving a truth table for this expression would be the tilde. So we're looking at underneath the conjunction sign and underneath the tilde sign to form the 4 values under this conjunction sign. So since we know the rule for conjunction, they have to both be true, basically, for it to be true. Let me know then in the first row, what's the truth value that is given here? Underneath that first row conjunction symbol, is it a T or an F? T or an F in the first row? F, good, Natalie. And why is that? Is it because the left side or the right side is false? The reason that the first row receives F is because which of the two conjuncts are false? Is it the left conjunct or is it the right conjunct that is false? Or is it both? In the first row. It's the right side, correct. It's this F here that falls underneath that tilde. Okay, so we saw an F under there, so that makes this a false conjunction. Now, in the second row, let me know. True or false? The second row, row 2. Row 2 of the truth table, under this main connective, good Ruby, also false. Why is that? Well, in this case, the right side was true, so that's fine, but this left side under this conjunction symbol was false. Therefore, it's a false conjunction, because they got to both be true for it to be true. In row 3, who can see the answer? Row 3 should receive a T or an F. Good, F. That's because of the left component. And then finally, in the fourth row, the truth value of row 4 should also say false. Good. Now, we're going to circle under the main connective here. Since we finished the truth table, we circle the final column that we filled in. And what is the status of this expression or sentence, logically? Tell me what status it has between logically true, logically false, or logically indeterminate. It is logically false, exactly. And I mean, if you think a little bit about the meaning in English of what these symbols are, that's, I think, something that really should be clear and intuitive. This is basically saying two things are true and also they're both false. That's impossible. It's like saying to somebody, I have an apple and a banana in my bag, and also I do not have an apple and a banana in my bag. So that's not possible. It can't be both the case that you have the two things and also, it's a contradiction. It can't possibly be true. It's a logically false statement. And you see that visually by completing the truth table, circling that column, and then just seeing what values are found within it. So that's going to be one major component of our truth table exercise. Taking individual sentences like we've done here and using the truth table method to analyze the sentence and come up with the answer as to whether it is logically true, logically false, or logically indeterminate. Now there's a little more truth table activity that we're still going to develop. Next thing on Wednesday, we're going to learn how to use pairs of sentences and with the truth table, determine whether they're logically equivalent or not. We'll also be able to use truth tables to determine whether a set of sentences are logically consistent or not. And then finally, we'll also be able to use truth tables to judge whether an argument is valid or invalid. So truth tables can actually be used to break down and analyze the logical properties that sentences, pairs of sentences, sets of sentences, and arguments have. And today we've just started by showing you how to evaluate whether the sentence individually is logically true, logically false, or logically indeterminate. So we're going to build on this next time by going over how pairs of sentences can then be placed within a truth table to discover whether they're equivalent or not. And just as a little preview of that anyway, you're going to have two formula in the bigger truth table. And then when they're both done and you see two circled columns, you'll simply look at them side by side. And if they're the exact same in every single row, like TT, FTT or something, then those two sentences are equivalent because they don't have different truth values in any one of the possible worlds, which are truth value assignments. And a set of sentences is consistent if after the full truth table has been displayed, if there's even one horizontal row where they're all true. That means it's possible for them to all be true at once. So we'll use these same methods of logical analysis to examine these features of sentences, pairs of sentences, sets of them, and arguments. So truth tables are the main goal and mission for this week and then next week. Your next homework is due next Monday, so you still got a good amount of time to work on that. That's just symbolization stuff. And then after we finish that, then we'll get starting our preparations for the midterm, which is just going to be basic concepts of logic, like from the first homework, symbolizations, like your current homework, and then like I'll throw in a problem or so about truth tables as well. But I won't emphasize it as much because there are further homework assignments involving it after the midterm. Okay, everybody, so good meeting. Thanks everyone for your attendance. I didn't use the Zoom today because I just wanted to kind of work with the board more, but as we do more practice problems, I may go back to the dual format on Wednesday, but I'll definitely let you know either way. So, all right, everyone, hopefully you're having a good day so far, and I'm wishing you guys well. Let's be back on Wednesday, and let me know if there's anything that you need. I'm checking my emails all the time, so thanks again, and I'll see you guys back soon. Okay, bye-bye.